Someone asked me to make a video about loops, and I thought I'd take this opportunity to go into quite a lot of detail about loops. So we're going to start very easy and then get a little bit more complicated because the loops that we've got access to have got a lot of power. So the first one that people are mostly used to is just the kind of for loop doing something fairly basic. And so the two main ones we'll see are in a range, and this is an iterator that gives us the numbers from 0 to 9. So we just run that and it goes, it runs all the way down to 9. So that's kind of straightforward, and we can use that for all sorts of things, but usually we'll be looping over the items in a list. And so if we want to print out these names in this list of names, then we just say for name in names. So for temporary variable name, which will be used inside the loop, in collection, print that temporary variable name. And then as we loop around it, and we go around and around and around, we get each one of these things in turn. Loops will go in the order that they're in the list, so that's nice, it's kind of helpful. And you can do something with it once you get to it. So we've seen this pattern before a lot. The idea that we have a bucket or a container or a collection, whatever, and it's empty, and then we loop through something, and in this case it's the list of names, and we want to do something to that temporary variable, which is the thing in the list, and then put it into the bucket. And so if we run that, we can see the length of those names. It's 2, 3, 4, 6, 5, 1, and 9. So we've done some processing on that and put the stuff into the bucket. And one of the things that we have found is that we do this so often that there's a Python structure for it. So the list comprehension does exactly the same thing as the thing above, but it does it in one line. And because we've got those brackets on there, the square brackets or the staples, we can say that we can do all of that stuff in a single line. It's very terse, it's very quick, and it's very much a sort of Python pattern that people like to use. So for loops are pretty straightforward. They just go through a list of things or keep hitting an iterator until it runs out, and give us back some kind of value. While loops are a bit more complicated in the sense that they require you to do a bit more stuff. And so we say while some Boolean condition is true, keep doing this stuff. So while this Boolean condition is true, keep doing this stuff inside this loop. The risky thing with while loops is that you can go infinite. So you've got to be very careful that they have some kind of termination condition. So if we run that, it just prints the numbers from 0 to 9. If we made that 5, it would print the numbers from 0 to 4. Now, if we have some kind of unknown thing inside our while loop, so like we were doing with the guessing game or with the binary search, you can either go while true and loop infinitely and have some way of getting out, or you can do a while with a guard. And so a guard is just a variable name that I'm using here, but you can use it, you can call it anything you like, but the idea here is that we have two conditions. So while the guard is less than 10 and the coin is tails, so this little thing just randomly flips a coin, and so it will keep flipping until we get a head. So while the coin is tails, keep flipping, and the guard is less than 10. But this is, it's unlikely that it'll ever go past 10. But just hypothetically, if it was a sort of weird situation, it might just keep going forever. So often you see these things in, let's say as a video game, like while my character hasn't done something, keep looping. Now if your character can never do that, it will just keep going forever, and a computer will lock itself quite happily. So in this case, we've got the coin is randomly picking between these two things. It's picking one of those values out of that list and then returning the first thing in that list of 1. So we then print the coin and we print the number that the guard has got, and then we add 1 to the guard. And so the whole idea is that every time we add 1 to the guard, regardless of what the other value is, we will always break out by the time we get to the number of the guard. So if we run that, so that's quite a long run of tails. So we got tails 3 times. So tails, 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 and then we get heads and we break out. And so just to show that we can nest things, but also to show you what the kind of likelihood of these things is. If we run that, we see tails, heads, tails, heads, heads straight away, tails, heads, tails, heads. We can keep running that and just see a few times like what we're going to get. And these are coming up pretty short. There's a long run. But if we had a situation where we were worried that this thing would never complete, the guard will be there to stop it from locking itself. And you can add something along the lines of, you could have a message or an error or something along those lines that when it hits the guard, then it gives you a little message and says, okay, we're going to terminate this now. The other thing to note in this one is that if you're doing a for loop like this, for instance, it's a pretty straightforward thing, like 5 times do this thing. If we're not intending to use the local variable here, we can put in an underscore as the variable name, and your editor will realize that that's a Python convention for I don't plan to do anything with this variable. It doesn't make any difference. You could print that underscore if you wanted, but it's just very, very bad form because there's a sort of accepted sense that you're just printing, you're using this underscore as a throwaway variable that you don't ever intend to use. Right, so just as a little side idea here, we can do unpacking assignment in Python. So we've got this tuple of 3 things. We also have these 3 variables that we can unpack into. And so when we run that, we can see that A is the blown mind, B is the cake, C is the tangerine, it turns out, not an orange. And so the idea of one thing returning more than one value is used a fair bit in Python. And what that means is that we can do a bunch of things with it, and we'll get to that in just a second. So we have this enumerate function, which is very useful, and let's see what it does. So it makes a tuple of an index and the value. And so often you'll see people who don't know about enumerate running through a kind of thing that looks a bit like this: for I in range len names, which is kind of gross because you have to then keep referencing the main collection. Whereas the enumerate allows you to work with the value, but also have an idea of where you are in that list. And so that's useful if you want to say something like, how much longer is this value than the one before it in the list, or the one after it in the list, that kind of thing. And so if we unpack that, so remember unpacking is this idea that you can put multiple values from a tuple into multiple inputs. We can unpack inside a loop controller, so for index and name in enumerate names, then we can print the name, the length of the name, and the index times 5 in this case. So when we run that, why is that being saved? Okay. So we've got the name, the length of the name, and the index. And that's sort of a toy example. It doesn't really do anything useful, but it's a very useful thing when you're actually working. And so very similarly, we have some ways of doing things like that in pandas. So we've got this data set, which I made last night because I've got nothing better to do. And we now have a data frame of these lovely humans who make up BTS. So what can we do with this data? If we do what we would expect, which is for row in BTSDF, BTSDF is the data frame around BTS. What we actually get, instead of each row one by one, which is what I always think it should do, we get the list of the columns. So the column names here. And so what this is for doing essentially is for looping over the columns, which is not kind of how you would expect it to work. Does that make sense? So we've got this weird thing here, and what we really want to get is the rows usually. So if we want to run through the rows, we can do something like this with df. We've got a data frame and it has a function called iterRows, which returned the rows one by one, much like enumerate. So we get the index of the row and the row. So let's run that and see what we've got. So the index here is a number. The only difference here from enumerate is that if your index is not a number, it will give you whatever your index is. Indexes in pandas don't have to be numbers at all. They could be names, they could be dates, whatever. And then we have this string, which has got a bunch of string formatting stuff in it. So we say real name, blah, blah, blah. And this is the format that they get in the Wikipedia article. So if we want to print out all of these as if we were making a Wikipedia article, then we can do it like that. Now, the other way you could do that, instead of doing a loop, is we can use an apply. So this apply, we make a function called blurb, which returns that value, and then when we run that, it just gives us the same values back, except it gives us it back as a pandas series. So what we could do is make a new function that, for instance, calculated the person's age. So if we wanted to use an apply to add a new column, we're basically looping over all of the rows and making a value out of that. Because it returns a series, we can just add that straight in as a column. So I've pinched this function which formats time deltas. So a time delta is a distance between two time stamps. I pinched this from a Stack Overflow answer and made a little function which gets the age, and so that turns the date of birth string into a timestamp. This one, the now thing, just gives us what the time is right now, and the delta is now minus the date of birth. So let's say 2021 minus 1995 gives us 26, I think. So what we're going to do is say this new data frame, the age column, is the data frame dot date of birth dot apply, and then the get age function. So this, like, instead of writing our own loop, this handles it for us. And so we run that, and we can now see that RM is 26 years old. We can see that Jin is 28 years old, that kind of thing. So we can very quickly see that Jin is the oldest. So the whole point of this is that there's no best loop. There's no correct loop to use in all cases. It's just a case of what is the best loop to use in any given context. So I hope that makes sense. If you have any other questions, then just ask.